That's what we're doing here, right? Now, to find our d, though, to find our distance, we actually have to use what? We have to use this function, right? Because this function gives us our distance as a function of what? We input what? T, which represents time, right? You're going to punch in the time to figure out how far that person has traveled in terms of distance. So this gives you your distance. Right? So in order to figure this out, you're going to say f of 3 minus f of 2. And what times are you going to put in the bottom? 3 minus 2, right? And how did I know that it was 3 and 2? Well, yeah, in the problem it says we're looking for the second and third hour, right? And every hour is t. All right, so we plug this in to the formula, we say f of 3 is equal to negative 1.33 squared plus 12 times 3. That's going to give you 24.3 miles. And if I plug in 2, negative 1.3 times 2 squared plus 12 times 2, that's going to give you 18.8 miles. And what's nice about application problems is sometimes they make sense. Does anybody know how long a marathon is? 27. It's 27 miles? Yeah. 20, something like that, right? So notice this makes sense, right? That this runner's running a marathon. They've obviously will go 18 and then 24. Right? All right. So we plug those in here. 24.3 minus 18.8. What's 3 minus 2? 1. So we got lucky there. Okay. So all we really have to do is just subtract the top, right? All we have to really do is just subtract the top. So when I do that, what do I get? 5.5, but we got to put what after it? Miles per hour, right? So again, when you're talking about velocity, you have to put that miles per hour, right? Because again, you're talking about one unit of thing related in relation to another, right? Okay, so we've done that, but we only found the average velocity, right? We found the velocity that the runner runs on average between the second hour and the third hour, right? Now, what if the question would have been phrased like this? Leslie, could you read this?
The distance in miles that a runner competing in a Boston Marathon has traveled at a certain time t and hours can be found by f of t equals negative 1.33 squared plus 12t. What was the runner's instantaneous velocity per hour of the race?
Yes, good. So, what is the difference here? It's asking us for what? What kind of velocity? We want the instantaneous velocity, right? This is the key word there. And what is the root word of instantaneous? Instant, right? And when you hear instant, that means what? That right then, right? Like you're an instant winner, right? You instantly have Amazon Prime send this to your house instantly, right? Apparently they can do deliveries, same-day deliveries now. So, instant, yeah, means you want it at that exact moment, right? The same for instantaneous velocity. Rather than finding the velocity over a certain interval of time, you're finding the velocity for one period, one frame of time, right? But there's a problem here if you try to use the average velocity formula. And what is that? What happens when you try to use that one? Yeah, you're subtracting the same distance from the same time, so you get 0 over 0, right? So again, this is the same tangent line problem that we ran into yesterday, right? Yesterday was a little bit more of a mathematical, theoretical sort of thing that we kind of did the slope, then we did the tangent line, right? And it was a little abstract. Today's lesson, hopefully, I hope to kind of get you to think of it in more real terms of why the tangent line problem actually is a real problem, right? Because if it's the case that an object has some movement at a point in time, right? I know that an object's moving at all times. Why? Because I can clearly see the runner moving, right? The runner moves from A to B, so clearly it's moving. So But mathematically, when I try to figure out what the average velocity is, I'm running into this problem. So there has to be a way around this problem to where we can divide by something close to 0 but not quite it. And what is that? How can I approach 0? We need what? We need to use the limits, exactly. And so that is on the next page. Alright? So yeah, we got to use limits. So defining instantaneous velocity. Notice this formula is exactly almost the same as yesterday's formula, except now we're dealing with things that are a little more tangible, right? So your velocity is equal to the limit as h approaches 0 of the distance in time plus h, right? Minus time distance as is with time plugged into it. Now notice here, this is saying time plus h, right? What does that mean? So say for instance time here was 3 seconds, right? Say time here was 3 seconds, right? What would time plus h be? 3 plus h, right? But h is approaching 0, right? H is approaching 0, as said by the limit, right? So you could think of this as like maybe time is like 3 plus 0.0001, right? Like you're adding on something infinitely small to it to see what happens, right? Because you're technically still not dividing by h. But that's the way to think about this, is you're taking one distance that's just slightly bigger or smaller than your time, and you're subtracting it from the time, right? Okay, so limits help us out here. So let's see if limits can help us with this problem. Somebody want to, Sarah, you want to read?
A baseball is dropped from the top of the 2,000 feet top of the building. The height of the baseball is c after 2 seconds is given by f of c equals 2,000 minus 16 c squared. Find the instantaneous velocity of the baseball at 5 seconds.
Okay. So we're asked to find the what velocity? Again, instantaneous. Good. So for this one, we're going to, instead of using the average, we're going to use that limit one, right? So your instantaneous velocity is equal to the limit as h approaches 0 of f of t plus h minus f of t over h, right? So we're going to use that formula there. So we're going to plug stuff in. Now, remember right here, what this is basically saying, so I'll start it up for you. So what this right here is basically saying is that everywhere you see a t in the function up here, instead of plugging in a t, you're going to plug in a what? What are you going to plug in? 5. Not 5. Remember what we did yesterday? What did we do yesterday? Plugged in what? Yeah, the form, which is, what's inside here? This is t plus h, right? So everywhere I see a t, I'm going to plug in t plus h. Yeah, not 2,000. So this is going to be 2,000 minus 16 times what? There's a t here, but instead I need to put what? Yes, good. And that gets squared. Right? So all of this stuff corresponds to f of t plus h, right? I've just plugged in a t plus h wherever there was a t. Minus, remember to put a parentheses after the minus sign, because it has to apply to the entire function. And so then you're going to plug in f of t. So what goes after that? Yeah, you just plug in the function. Right? You just plug it in. And it's going to be over what? H. Alright. Okay. Alright, so what do we want to do now? Any suggestions? Yeah, we could do Xbox, but more of that goes with the overall theme. Doing Xbox goes with an overall theme of what? Starts with an S. You want to make things Simplify, right? You want to simplify everything. You want to distribute stuff. You want to do Xbox. Make sure everything's kind of by itself, right? Okay. So 2,000 minus, we'll leave that 16 in there for now. You do Xbox, or again, you could use that trick I showed you, or the difference of sums, where you could say, okay, t plus h, you're going to get t squared, so you just do the first one, plus 2th, you just put a 2 times the two things multiplied by each other, plus h squared, right? Yep, and that's a bit faster of a way, right? You just instantly get it. Also, if it's a minus sign in the middle, this is going to slightly change to where this in front of the 2 is negative. So just keep that in mind, if you choose to go that route. All right, what else do we need to do? Yeah, let's distribute that negative. Plus 16t squared over h. There is a last simplification step we need to make, and what is that? You said it. What'd you say, Ishmael?
Huh?
What'd you say?
16.
What about it?
Distribute.
Yeah, let's distribute it, right? Let's distribute that 16. 16t squared plus, or sorry, it's going to be minus 32th minus h squared minus 2,000 plus 16t squared over h. Okay? What's that? Yes, thank you. You know, it was weird. I forgot that in first period, too. I don't know why I keep forgetting that.
What?
There's a 16. I forgot to distribute the 16 to this. All right. So anything? Notice anything? What cancels? 2,000. You got a 2,000 minus 2,000. Anything else? 16t squared also cancels. So we're left with the limit as h approaches 0 of negative 32th minus 16h squared over h. And a good rule of thumb when you're doing these problems, when you're doing these limit type problems, is to say, oh, I'm probably going to have h in the top in every term here. Okay? So that's kind of a good rule of thumb. If you have h in the top for everything, you're probably on the right track. All right. So what I want to do to this, so can I plug in the h's to 0 yet? No, because why? I get what? You get indeterminate form, right? So what do I have to do? Yeah, pull out an h from the top. That's going to give us negative 32t minus 16h over h. What happens to those h's? They cancel. And we're only left with the limit as h approaches 0 of negative 32t minus 16h. And then what do? Now you plug that in, right? So then when you plug this in, what's going to happen to this term? It's going to go away, and you just get negative 32t, right? So again, what is this number saying, negative 32t? Well, it's saying that the rate of change, or the baseball falling, falls at a rate of 32, what? Not 32t, yes, but what units? Feet per second, right? That sounds familiar, doesn't it? Negative 32 feet per second. Oh, have y'all only learned it 9.8 in physics? Yeah. If you were to do it in standard or American units, this would be gravity's pull, negative 32 feet per second squared, right? But anyway, so if I want to find out, so it's asking me for the instantaneous velocity at 5 seconds, so what do I have to do there? Plug in 5. So plug in 5, negative 32, times 5. Remember that little mental math trick that I showed y'all? That when you're multiplying by 5, what can you do? Yeah, you just chop it in half and then add a 0, right? So 32 in half is 60. So your answer is going to be negative 160 feet per second, right? Why is there a negative in front of this? Yeah, when it's falling, right? It's falling. One other thing I want to point out before we move on to is that there's something slightly wrong with this equation, because at some point this ball has to do what? Yeah, it has to hit the ground, right? And so that's kind of what's slightly wrong about this problem is if you plug in, like, say t equals 1,000, you would still get a number, but obviously you wouldn't be correct because you would be like in China, right? That wouldn't make any sense at all. So, all right, let's go ahead and turn to the next problem. All right, so what I'd like you to do is just go ahead and kind of set up the initial equation that we want to work with. Right. So take about 2 minutes. Try to set up that initial equation that we're going to be working with. Okay, all the juniors are here. All right, so let's take a look at this one. April, can you read this problem?
The distance a particle moves along a path is given by S of t equals 36 c to the square minus 1. It moves 13 seconds in the distance of the particle from the starting point to the terminator. Find the equation for the instantaneous velocity v of t of the particle at any point in time.
Okay, so as we can see, S of t is telling us the distance that the particle travels, right? S of t tells us the distance the particle travels, right? So, when we find the tangent of that, so the tangent line or the equation that gives us the tangent line, that's going to actually give us the speed or velocity or how fast it's moving, right? So, let's go ahead and see how we would do that. Well, I'll let y'all help me out here, but I'm going to just say the limit as h goes to 0. I'll give you the fraction. Okay? So, how do I set this up? What's the first thing I want to write? First thing I want to write. 36, what? T plus H? Okay. Like that? Parentheses, good. What else? T plus H squared. Okay. Minus 1. Okay. Good. over h. Yes, good. I like that y'all are so meticulous now. Alright. Y'all clearly my students. Alright, so my goal by the end of this year is to like y'all go into calculus and Ms. Cooper be like, oh my god, y'all are so prepared. It's gonna be awesome. Unless y'all like completely slack off all summer, then all my work's just gonna completely.
Why would we be doing math?
Huh? Because math's fun. I need to have like a workshop or something over the summer so people can like do math. I don't know. Make it fun. Somehow figure it out. Alright, so what's my next step? Yeah, I want to simplify, right? How do I do that? Yes, but let's start from the left. Okay, so what do we want to do with that 36? Yeah, let's distribute it, right? So 36t plus 36h, right? And then what do we do, Abigail? Yeah. We got to use a Xbox for that binomial, right? Or we could use that thing that I showed, right? So I'm going to skip that. So it's going to be t squared plus what? 2th plus 8 squared. Good. So I got to do pesky Xbox every time. All right, minus 1. What do you think I should do with this negative? Yeah, let's distribute it. Okay. Now what? Yep, need the h. Always need the h. Okay, let me separate this a little bit. Okay, so now, last steps for simplification. What's the last thing you need to do to simplify? Yeah, let's distribute that negative 3. Right? So 36t plus 36h minus 3t squared minus 6th minus 3h squared minus 1 minus 36t. Woo! 3 squared plus 1. All over what, Ishmael? 8h. Yeah. Blank. You gotta be ready when I point at you. That's your time to go. Okay. Alright. So notice any cancellations?
36t.
Okay, 36t goes away. Anything else? 3t squared. 1. Anything else? Nope. And again, our rule of thumb holds here, which is what? Yeah, everything with a numerator has an h, right? Typically when that happens, you're in good shape. So the limit, as h approaches 0, and we're going to write everything that's left, so 36h minus 6th minus 3h squared over, good. Alright, next step. Good. Is anyone noticing a pattern here? Seems like we're doing the same thing over and over, right? So, 36 minus 3t. If you are noticing pattern, that's great, because when you start to notice that pattern, that's when you start getting really good, right? Because then you could just do the same thing. It just becomes a routine. What happens? H's cancel. We're left with the limit as h approaches 0 of 36 minus 6t minus 3h. And of course, what happens here? Yeah, you plug in the h to 0, or yeah, you make h 0, everything within h cancels, and you're left with 36 minus 6t. Which again, that is your, actually, make that your velocity, right? That's the formula for your velocity. 36 minus 6t is equal to vt, right? And again, notice your velocity is also dependent on your time, right? The time, how fast you're going depends on what point in time you are, because supposedly you're going faster or slower. Sorry. All right. Go ahead and run through the rest of those 3. Go ahead and run through the rest of those 3. I'll give you about take about 3 minutes to run through those. Take about 3 minutes to run through those 3 problems. That's how you know when someone's like talking about you. When like you get that weird like chilly feeling. Like, yeah. No, that's right. It's when your ears burn. What does the chill mean? Something bad happened, right? Oh, okay. Ghost. I guess ears burning is just ridiculous, right? I think most people got this. So, at t equals 5, what do I have to do to figure out what direction, what velocity? Yeah, you just plug in 5, right? To the velocity thing. That's 36 minus 30. That's going to give us 6, what? Centimeters per second. Okay. What about at 1 second? Minus 6 times 1, which is 30 cent per second, right? And so it seems like this is doing what? What is this particle doing? If at 1 second it was going 30 centimeters per second, at 6 seconds it's going 6. What does that mean? It's doing what?
Slowing down.
It's slowing down over time, right? Slowing down. And so, last question, it says, when is the particle at rest? Right? So, when is this particle, what does it mean for it to be at rest? It stops, right? It stops, meaning that its velocity is 0. So, what can we do to this formula, this velocity formula? We can set it equal to 0, right? We wouldn't plug in 0, because that would imply that what is the distance or what is the velocity when time is 0, right? Instead, we want to know what? When does it stop, right? When is it not moving? So we set it equal to 0. And that's some pretty simple algebra here. Divide by 6, t is equal to 6, right? And so at 6 seconds, the particle will stop. Now, one thing I do like about this question is kind of illustrates kind of the importance or why calculus makes things so much simpler. Because again, up here, this was a lot of work, right, initially. But once we got past this and we got this equation, everything was just what? Easy, right? We're just able to plug stuff in and do it, right? That's why calculus is so nice. The other thing too is a lot of the equations in physics that you've learned with Mr. Terry are like what? He's like, just use this formula and the answer will pop out, right? Kind of, right? What happened was when Newton and Leibniz invented calculus, they were actually invented to figure out those formulas. So calculus actually, if you use it and use logic and are able to kind of go through the math, you can actually derive the formulas that you use in physics using calculus methods, particularly differential equations, but you'll learn about that later. One last thing before we finish. A segment on the show I like to call, that's interesting. So, one last, thank you, Abigail. Let's say I look at that function that we looked at initially, right? F of t is equal to negative 1.3 t squared plus t, right? Well, actually, I'm just going to write out the ones that we did today. So let's look at all of them. 2,000 in the second problem, t squared. And the last one with the particle was s of t is equal to 36t minus 3t squared minus 1. Okay. So let's look at this second one. Right? Let's look at this second one. What if, just for fun, for giggles, right? I'm going to forget about this 2,000, right? And I'm going to multiply this negative 36 by the exponent. So I'm going to pull the exponent in front. So negative 16 times 2 is what? 32. And also I'm going to take 1 away from the exponent, so I'm just going to make it t, right? What was the answer to that problem? Negative 32t. Let's try it one more time. Alright, going to do that again. So t right here, when it's just t, what do you assume the power here is? 1, right? So I'm going to multiply that by this power, so 36. But then I'm going to take 1 away from the power, so 1 minus 1 is 0. And what's anything to the 0 power? 1. So this is just 36. Do the same thing here. 2 times negative 3? Negative 6. And I'm going to take 1 away from the power, so t. What was the answer to that problem? That's interesting, right? So, tomorrow, there's actually a much, much faster way of finding the slope of a tangent line at a point, right? And we're going to talk tomorrow about the bread and butter in our final foray into calculus. We're going to talk about what is a derivative and how do you find it and what does it mean. Okay. So tomorrow, that's the preview for tomorrow. We're going to be talking about derivatives, which you're going to do what? Watch online, right? Because you're not going to be here tomorrow. So you should. Huh?
Sorry, what's tomorrow?
Don't you have your